Hello, Vadim. So just so you know, we're planning to record this and post it to YouTube, and you're okay with that?
Yes, I'm okay with that.
All right, very good. Then we will get started.
Hello, my name is Vadim, and I will be talking about DevOps for HPC operations today. The scientific software development is almost synonymous to HPC. And an HPC engineer always tries to be wise about resources available. So we keep our instruction pipeline full. We fully utilize the memory bandwidth. We micromanage the NPI communications and aggregate our IO transactions. On top of it, each facility has a limit on the power available and the heat it can dissipate. But above all, there's people who develop, deploy, and run software. We humans are the least scalable and the least reliable component of HPC. And I deliberately use the word component because unlike everything else in this list, humans are not a resource. So as Fred Brooks pointed out once, adding manpower to a late software project makes it later, which essentially says that software development does not scale up on demand. This was the main conclusion of his famous 1975 book, The Mythical Man-Month, also known as the Bible of software engineering, because everybody quotes it, some people read it, and few people go by it. It became a cultural phenomenon these days, and unfortunately, people forgot that was written for very practical purposes. Teach software engineers about do's and don'ts. A decade later, Fred Brooks published yet another essay called No Silver Bullet. And the conclusion of this essay is that there's no promise of improvement of individual productivity of software development. If you combine these two statements, you can see that we have a problem with coding. It neither scales up or accelerates. It would be pretty disappointing for people who focused on developer productivity, but you shouldn't. While improving developers' productivity is important, coding is just one part of a larger picture. There are many other aspects of software technology that constantly toll our budget and beg to be improved. I strongly believe that the bigger prize is in optimizing the entire software product pipeline or even entire ecosystem. At the end of the day, search over a larger space always yields a more optimal result. One doesn't need a looking glass to spot a candidate for improvement. There's a widespread misconception that software is ready for use once the code is completed. And putting it to work is just a trivial routine step that somehow happens on its own. In reality, the road from developers' working copy to the end user is long and rocky. And software developers are not strangers to Murphy Law. They know that whatever can go wrong will go wrong. This is just few examples. So build gets broken due to the system library update. Production cases fail after new release, or recent trunk updates break downstream integration tests. Tests that were passing on developers' machine strangely fail on the production server. And today's results are different from the yesterday's. And so on and so on. So this multiple mishaps, mysteries, and inefficiencies quite common. And if left unchecked, they start steadily hog your time, drain your resources, and destroy your reputation. And if you think that little mishaps have little consequences, think twice. There's plenty of examples when simple and invisible problems were derailing a critical mission. In 1991, a Patriot missile missed the target due to a round of error. 28 people were killed. In 1996, a bogus cast from floating point number to a 12-bit integer triggered self-destruction of Ariane rocket. And in 1999, NASA lost Mars Climate Orbiter due to the unit disagreement between two components. And bad things didn't start in the 90s, as you may think, looking at this list. Apparently, even 7 centuries ago, people knew pretty well that devil is in the details. Lots of productivity, contingency, and quality issues can be mitigated or eliminated with proper DevOps processes, policies, and tools. What is DevOps? DevOps is a popular concept that combines software development and IT operations. There's plenty of definitions floating around. They're pretty vague about the essence of DevOps, usually citing features like mindset on productivity, highly automated processes, and frequent releases. But they all unanimous about the ultimate goal. The ultimate goal is timely delivery of high quality software to business, to the end user. I risk to offer yet another minimalistic DevOps manifest, DevOps definition, that I think can be used to explain the driving forces behind DevOps. So first of all non-coding tasks like building, testing, integration, and deployment are critical, integral parts of the software product pipeline. And all these tasks should be assigned to the development team. Everything else, automation, short delivery time, mindset on productivity, are just natural implications of the positive reinforcement mechanism created by consolidating development and operations in one hand. Why does it work? First of all, consolidation prevents diffusion of task ownership. Nothing falls between the cracks because the development team right now owns almost entire product pipeline. At the same time, it encourages wide range of optimization. It's much easier to optimize over the longer workflow than optimize each component separately. And all this optimization are internal to one team, so there's no bureaucratic barriers between them. And the team itself benefits from any improvement done on other side of the fence. So custom automation prevents otherwise inevitable human errors. Systematic testing discovers bugs before they surprise the end user. And power to customize the environment greatly simplifies the configuration and integration tasks. All these gradually reshaping your product into more maintainable, testable, and deployable. An important thing to remember is that formal transfer of responsibilities does not really change anything unless it also grants the developer team freedom to operate, freedom to select the right tools, and freedom to customize testing and production environments. If you are sold on DevOps, the first question you should answer is whether you do it yourself or you assign it to somebody else, or metaphorically speaking, whether you take a red pill or a blue pill. Blue pill may solve a lot of problems, but DevOps is not one of them. So you really have to roll up your sleeves and get your hands dirty. There's plenty of reason to do DevOps yourself. Any custom automation requires intimate knowledge of product and environment, and nobody but developers know everything about it. Each HPC system is unique, it's far from being static. So you should be ready for active support. And it's very hard to provide active support with third-party products. While many of DevOps tasks and activities fall into the category of IT operations, it is critical not to delegate them outside the development team. Involvement of developers in daily operations has enormous positive impact on the quality and usability of DevOps components. The best piece of software around were created for personal use. Unix, C language, Perl, Tech, Git, just to name a few. DevOps is not a walk in the park. There's plenty of cultural and technical challenges associated with DevOps. IT operations frequently underappreciated and mistakenly viewed to be secondary to coding. They have hard to measure deliverables and suffer from negative visibility. I use the term sysadmin curse. Smooth operations are usually taken for granted. Occasional screw-ups generate negative feedback. There's a lot of responsibility associated with IT operations, and there's not so many volunteers willing to do this job. So people in the trenches, they feel the management attitude towards IT operations. Nobody's willing to take this job on its own. At the same time, this job requires special skills, conservative attitude, and highly scattered unstructured subject knowledge. As one of my colleagues once said, they don't teach this stuff at school. On top of it, there's a constant pressure to provide immediate solution rather than a sustainable, manageable, or a scalable one. There's plenty of challenges on the technical side. We already mentioned that the production environment is constantly evolving, and DevOps layer has to catch up promptly, almost immediately. DevOps is about 24/7 operations. So there should be a lot of robustness. Mishaps are part of our life, and DevOps layer should embed full diagnostics, have good recovery potential. Applications team, unfortunately, don't have root privileges, which limits the choice of tools. You really have to stick the basic tools available on Linux. It will also require a fair amount of tinkering for finding robust workarounds. It's all about automation. Automation helps you to take full control of routine tasks and leave developer and integrator no chance for a mistake. Automation is not a rocket science, but it takes significant effort to fit moving parts and make them robust and user-friendly and keep them running smoothly ever after. Automation requires discipline and imposes constraints on your workflow and the product itself. You cannot just apply automation to existing environment. You really have to shape environment to make it automation friendly. Automation does not tolerate low quality components. It is incompatible with complex workflows, rich configuration space, and it's also incompatible with bureaucracy. You have to try to keep everything as simple as possible. Settle for fit for purpose solution, focus on essentials, minimize nice to haves. Routine tasks should require zero effort, and robust defaults are really vital from this perspective. Be defensive, shield your project from surprise factors. Impose strict versioning of all the components. Stage all the third-party dependencies. Never use them as a black box. Always provide a wrapper for your own product. Your HPC skills make them very handy implementing DevOps, because the performance of DevOps tools is critical to provide quality experience for developers. Your build time shouldn't exceed 5 minutes. Your test time should be 5 minutes max. Otherwise, nobody will run the regression test suite. Your regression comparators gotta be smart in order to minimize false positives. And once again, you have to keep your workflow simple and transparent in order to diagnose possible mishaps. And you also have to collect as much diagnostics as possible. To sum it up, in order to have a successful software development shop, you have to recognize the importance of no coding tasks, take control of little things before they take control of you, and remember to take a red pill. Do it yourself. You don't need fancy tools or third-party services. Everything can be done using standard Linux utilities. And please remember, there's no free lunch. Always allocate adequate resources for your DevOps. Thank you so much.
Thank you, Vadim. Very nicely done. May I ask a question or two?
Oh, sure.
We have time, so let's do that if that's okay. So I had a question, integrating the DevOps pieces together, right? So you have development, as I understand, development team members and IT team members, and you want them to be part of the same team. Is that correct? Is that a fair statement?
It's a fair view. Ideally, I would like to see developers participating in IT operations, and I would like to see IT folks participating in development as well. Yeah. Documentation is never adequate. The only way to learn something about the product is to read the code, fix the bugs, participate. So there should be mutual penetration.
Yeah, yeah.
There shouldn't be division between IT and development people. It should be one team, really one team with great skills.
Very good, very good. And then, so in some organizations, there tends to be a separation between those two, right? The development team is handled one way and the IT team is handled the other team. Have you seen ways to bring those teams together so that they are essentially one team?
I guess the short answer is no, because there's different metrics and different objectives for each separate team. Unless you really declare them to be one shop, they will optimize things so that they're convenient for the team.
Yeah.
Unite and conquer approach is really about optimizing the entire workflow rather than optimizing some component of it. And you're lucky to have IT folks on your side listening to you and implementing things the way it's convenient for you. It can be done if you are a major project on the system.
Yeah.
Your project, you have much less leverage or negotiation potential in order to do things your way. And this is why you really have to work around the existing system, existing tools, and make it convenient for you. It shouldn't be discouraging. Judging from my experience, everything can be done if you are persistent achieving your goal. And you have to remember you're working for yourself and for your team. You know, you are the first one who reaps the fruits of optimization. So there's a driving force behind it.
Yeah, I think that's a really important point, that, you know, having these people be together on the same team is an essential aspect of high quality, effective, and efficient software. I think that's a very important point. Yeah, very good. All right, any other last minute comments?
I hope you guys will come to the online workshop, July 21st, 23rd, and we'll have a chance to talk again about everything that we didn't talk today.
All right, very good. Thank you very much.
Thank you, Mike.